Hey, this is Michelle Kittner from the Gulfport School District, and this is the second video in a two-part series on circles. By the end of this video, you'll be able to find the area of a circle when you're given the radius or the diameter. In the first video, you found the circumference. So if you're still struggling with circumference, you may want to go back and rewatch the first video. The standard that goes with these videos is 7.G.4. Let's quickly review the vocabulary. We discussed it in the first video, but we'll go over it real quick again. Remember, the circumference is the distance around the circle. When you draw a circle, you draw the circumference. And we talk about circumference with a capital C. The center of a circle is just the center, the point inside a circle that is equidistant from each point on the circle. So no matter where I pick on the circle, around the circumference, it's the same distance to the center. It's the center of the circle. The diameter is the distance across, but it has to pass through the center, all the way across. It can be anywhere all the way across. It just has to pass through the center. It cuts the circle in half. And the radius is the distance from the center to any point on the circle. So it can go anywhere. And remember, we decided that the diameter is 2 times the radius, or you could say a radius is the diameter divided by 2. It's half the diameter. And then pi is the ratio of the circumference to the diameter. It's represented by this Greek letter pi. It's about 3.14. Okay, area of a circle. These are the formulas you'll need to know, and they're the same thing. Remember, these are the same because when we have radius times radius right here, we can shorten that. It's the same as radius to the second power, or radius squared. But let me show you where this formula comes from. So we have this circle, and I broke it down into quarters for you, into fourths. Now I'm going to take these and I'm going to line them up to make a wave. Okay, so now when we make that wave, this piece right here is a radius. This right here, this pink side, is the radius, right? Because it goes from the center down to the edge of the circle. Okay, this is half the circumference, right? Because I took this quarter of the circumference and this quarter of the circumference and I put them together, so it's half. Same with the green. Green represents half the circumference. You could say circumference divided by 2. Same thing. Let's look at it again, but divided into even smaller pieces. This time I divided it into sixths. So let's take our Gulfport Admirals circle here and put it together to make that wavy line. See, it's not quite as wavy. It's getting a little more steady, a little straighter along the sides, and less big waves. They're smaller now. But this is still, this piece right here, this piece right here is still a radius. This over here, this edge, is still a radius. This is still 1/2 the circumference. This is still 1/2 the circumference. All right, I did one more, even smaller. And it's the same. This edge right here is still the radius. This edge right here is still the radius. But notice again, it's getting less wave-like and more like a rectangle, right? This side over here is still half the circumference, or the circumference divided by 2, not d. That would be pi. And this piece up here is still the circumference divided by 2. Now imagine we did this smaller and smaller and smaller and smaller. It would eventually just be a rectangle. And this is how we came up with the formula for area of a circle. Because remember that the circumference, we said, could be 2 times pi times the radius, right? Now, we only need half of it. If we have area equals length times width of a rectangle, and we know that the length is circumference divided by 2, we're going to circumference divided by 2, circumference divided by 2. Okay, so circumference divided by 2 is pi times the radius. So we know that this is the same as pi times the radius. And this side is just the radius. So area equals pi times the radius, that's the length, and the width is another radius. Okay, so area equals pi times radius, or pi times radius to the second power, pi times radius squared. So that's where that formula came from. It's super important, and I hope explaining where it came from helps you understand it a little bit more, but you've got to remember it. So let's see. If the radius of a circle is 1.5 feet, what is its area? Use 3.14 for pi. Okay, so let's see. Area equals pi times radius squared. So let's plug in what we know. Area equals 3.14 times 1.5 squared, 1.5 to the second power. So we have we've got an order of operations says to do the exponent first. So 3.14 times 1.5 squared is 2.25. Okay, next in order of operations that we can do is multiplication. So 3.14 times 2.25 is 7 65 thousandths. Now we can't forget our units, gotta have units. Feet squared. So the area of this circle is 7.065 feet squared. Okay, here's another one. I want you to try it on your own. But on this one, I gave you the diameter. So you've got to remember that radius is diameter divided by 2. It's half of the diameter. So give it a shot, and we'll come back together in a minute and work it together. Okay, if you're not done, go ahead and pause your video and finish it up. And then when you're done, restart, and we'll go over it. So let's see. Let's find the radius here. We have the diameter of 4. So we know that the radius equals the diameter of 4 divided by 2. So the radius is 2 centimeters. Okay, now let's find area. Area equals pi times the radius squared. And plug in what we know. Area is 3.14 times 2 squared. Order of operations tells us that we need to do the exponent first. Area equals 3.14. 2 times 2 is 4. Times 4. Area equals 3.14 times 4 is 12.56. We can't, that's approximate. Remember, area, anything with pi is going to be approximate. So area is approximately 12.56 centimeters, and area is squared. So centimeters squared. How'd you do? Did you get it? All right. Now let's do a little bit of a more complicated one. Find the area of the blue regions of the square to the right. Use 3.14 for pi. So let's see. We can find the area of the square. So let's start by finding the area of the square. An area of a square is just side times side. So we have 5 times 5, 25, these are feet, square feet. Okay, that's going to come in handy in a minute. It is important. Let's look at this. If this is the center of the circle, it's not right there. And this goes down through the center. then this length, the diameter, is going to be the same as this length. So the diameter here, 5 feet. So we'll put that over here. Diameter equals 5 feet. 5 feet. Remember, the radius is the diameter divided by 2. And we need radius to find area. Diameter divided by 2, 5 over 2. Radius equals 2.5 feet. So each of these pieces is 2.5 feet. Okay, let's find the area of the circle. We know area equals pi times radius squared. So let's plug in what we know. Area equals 3.14 times 2.5 squared. Okay, remember, order of operations tells us we have to do the exponent first. So we have area of a circle is 3.14 times, and 2.5 times 2.5 is 6.25. Okay, now we can do the multiplication of 3.14 times 6.25, and we get 19.625 feet square. Now, right now we have the area of the big square and we have the area of the circle. But what we're looking for is the total area of these blue pieces. So if this is a cake and we took out the circle, how do we find the area of what's left? Well, if we took this out, then we subtract. So we have 25.000 minus 19.625, and that is 5.375 feet square. So the area of just the blue pieces is 5.375 feet square. I hope that helps. If you're still struggling, maybe go back and watch the video again just to work through these problems again and understand the concept of circle of an area of a circle.